Hey guys, welcome to Unit 8A, Section 6, which is angle relationships in, on, and outside a circle. So the first idea here is, if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half the measure of its intercepted arc. So this is very similar to those inscribed angles. So the idea is the arc from A to B, in comparison to 1, is that it would be 2 times larger, and the arc from A to C to B would be 2 times larger than angle 2. So you'll see this in the next example here. Here we have angles 1 and 2. We know that the arc that corresponds to angle 1 is 172 degrees. We're assuming that this line is tangent right here. So all that we have to do to find the measure of angle 1 is to take 172, divide it by 2, and we're going to get 86. So it's just half of that corresponding arc. Now, the measure of angle 2 is a little different because we don't know what this arc over here is. We need to figure out what the value from that point here to this point over here is. So what we would do is we know that the other part is 172, so we could do 360 minus that 172, and that is going to give us 188 degrees. So if that's 188, that corresponds to angle 2, we're just going to cut that one in half as well, and that gives us 94. So that's the measure of this. Another way you could solve for this, though, is the fact that we knew that this was 86 right here. So if that's 86 degrees for this angle, it's got to form a straight line with angle 2. So we could just do 180 minus 86, and that's also going to give us the 94. So 2 ways to prove that one. The next part, if 2 lines, and this is the big thing because this is where we're going to get all the formulas. If 2 lines intersect a circle, there are 3 possibilities for the intersection point. So the case 1 is if it's on the circle. Now notice, if it's directly on the circle, what we get is an inscribed angle and its intercepted arc. So this relationship we've already seen, but the idea here, and this is missing in angle 1, the measure of angle 1 is going to be equal to 1/2 times A. So that intercepted arc is going to be 2 times bigger than our angle down there, so we just cut it in half. You could think of it, or the measure of angle 1 equals A divided by 2. That's another way you could get it. This one, again, we're missing this angle 1, so we're just going to put a 1 there. If we wanted to find this angle here or this angle here, since they're vertical angles, so they'd be the same thing, what we would do with this one is you would add the 2 intercepted arcs of A and B, we would add them together, and then we would multiply them by 1/2. So the measure of angle 1 is equal to 1/2 A times B, or the measure of angle 1 is equal to A plus B, those 2 arcs, divided by 2. It's the same thing, same formula. But we are adding up those 2. So we're finding the average of those 2 corresponding arcs, and that's going to give us our angle. Now this one here, the third example, imagine we were trying to find this angle. Again, we're going to call that angle 1. This one, it's similar to the last one, but we're actually going to subtract since it's outside. So we're going to find the difference between those 2. So the measure of angle 1 is 1/2 A minus B. Whatever your bigger arc is, make sure that goes first when you're subtracting because you don't want a negative answer. Or the measure of angle 1 is equal to A minus B all divided by 2. Either formula works for that. But we have to be able to recognize these situations. So let's go ahead and try out a couple problems relating to these formulas. First one, what is the measure of angle 1? Well, notice it's inside of the circle. This point is not at the center, and it's not on the circle. So we have to use the second formula, this one right here. So what we would do for this, I like to use I'm going to use this form of it. I'm going to add up those 2 numbers together. 120 plus 98, and I'm going to divide it by 2. So 120 plus 98 is going to be 218 divided by 2, which is 109 degrees. So the measure of angle 1 is 109 degrees. And that looks like a pretty reasonable answer looking at it. It's directly in between those two. The next one here, notice we have an angle outside of 45, and then this one you have to be really careful because we know what the angle is. Angle 1 is the angle here from our formula. So we know what it should equal. It should equal that 45 degrees. So we're trying to solve for x, which is one of the arcs. So this one you'd have to do 170 minus x, always the bigger arc, and 170 is definitely bigger, divided by 2. We're trying to find that arc for x. Remember, to get rid of a 2 on the bottom of a fraction, just multiply both sides by 2. So we get 90 equals 170 minus x. We're going to subtract 170 from both sides. Get negative 80 equals negative x, divide by negative 1. And we get x equals 80 degrees. Okay. So that one we had to definitely want to take a look at the picture before you just jump into the equation. Because we knew what the angle was, we had to find the arc that helped us relate to that angle. And then the last part here, calculate the value of x. So this time, notice we're missing the arcs, but we know that x is going to relate both of them, and we also know the angle. So just like in this last one, we're going to set 61 equal, think of it as a minus b over 2, just like with our formula up here, this formula, but we know angle 1. And then just fill in for a and b. So this is going to be our a, this is going to be our b, the big arc minus the little arc. So 61 equals, you have to make sure to put these in parentheses because there's two parts. So it's 10x plus 1 minus 5x minus 1. And you're going to see why we need that parentheses. The reason is because this negative sign, we have to distribute that to both parts. So I'm just going to write down at the bottom here. We end up getting 61 equals 10x plus 1. This becomes a minus 5x and a plus 1 all over 2. So let's combine like terms on the top of the other side. We get 10x and minus 5x gives us 5x. 1 and 1 gives us 2. And we got this 2 on the bottom. So now we're going to multiply both sides by 2 to get rid of that fraction. We get 122 equals 5x plus 2. We're going to subtract 2. There's a lot of just basic solving with this. 120 equals 5x. Divide by 5. And we're going to get x equals 24. I'm just going to pull that way up to the top. And we could plug it back in and check it just to make sure that our work is correct. But let's go ahead and look at this next one. So here we're solving for two variables, x and y. Just like usual, let's start by solving for x. So x is this inside angle, inside of the circle. So we want to look for the arcs that are created, which would be the 171 and the 77. Since it's inside, we're going to use that formula where x equals the two arcs added together. So 171 plus 77 divided by 2. So that's going to be 248 divided by 2, which is going to be 124 degrees. So x equals 124. Now for y isn't that tangent example, so you have to think about how we did this one up here. So we want to think about the arc that's going to correspond to angle y. So that's going to be this whole arc right here. So from this point here to this point here. So we want to add the pieces that make that up, which are the 30 and the 171. And then we're just going to cut that in half. So down at the bottom, I'm going to show my work. So 30 plus 171, and we're going to divide that by 2. So it's going to be 201. Cut that in half. We get 100.5 degrees. So that is our y. And looking at y, that does look like an angle that's bigger than 90 degrees, but not drastically larger. So it seems like a reasonable answer. Okay, and that is it for the Chapter 8A notes.